Hi folks, this is Gold Teeth, and today we're going to talk about the last step of gold extraction from electronics, that is the final acid pool and the final melting. So we set that up to here. We'll have chunks of gold copper alloy that will look like this, and what we want to do here is to remove copper so that we can have pure gold. So before we get to that, please make sure to like and subscribe and hit that notification button, and tell us in the comments if you ever had problem removing copper from your copper gold alloy and purifying gold. So in the previous steps we talked about how to remove gold foils from the electronics. So basically we want to heat up the circuit boards and remove the components. We talked about the best thing to use is an industrial dryer. We talked about the first acid pool that removes the gold foils from the surface of electronics, is only nitric acid, 65% nitric acid. And we said that it basically removes the copper beneath the surface that is gold, and the gold foils will float in our uh, fluid. Um, the reaction here is the same as the secondary acid pool and the final acid pool. The copper reacts with nitric acid and reveals brownish orange gas. So if we filter those nitric acid out, we'll have our gold foils. Our gold foils will look like something like this. Looks like something like this, and we want to clarify these. The gold foils that we receive from the initial acid pool are not pure, and if we melt them down we won't get a good result. So what we want to do is to alloy these with copper, so that the copper gold alloy will be in one place and the other components will be separated. Okay, so we said that gold copper alloys will look like something like this. It has uh, a feeling like it's gold. It has yellow color in it. Um, so we talked about the reaction, the brownish orange color of the gas. The point here is that this gas wouldn't stop until the copper dissolves in nitric acid completely. So a sign of the finishing of your process is that this brownish orange gas will disappear. So if you don't have any um, copper to dissolve in your nitric acid, this gas above your fluid will become white. And so you put the chunks down in the nitric acid, 65% nitric acid, and you will wait until the gas above your nitric acid uh, turns to white. And so the time can be really different, but the temperature should not be more than 35 degree. So you want a little above the temperature of the room. And for the uh, so you will get what you will get from the earlier process is these powders, the gold powders that is black and brownish. So this might look a little bit odd, but The gold, as we know in the shops and we use, is you know, bright, you know, yellow. You know, it's shiny light yellow. But the gold in nature, as and in laboratories, is um, a brownish black powder. And if you melt this down, you'll get that light, yellow and shiny gold. So the gold in nature is black. And the point of this process here is that this kind of powder that you have in the last process should be clean, and only the black powder and nothing else. Because if it has other components, like any other components, and for example, this place you have a big uh, amount of black powder, and in this place you have a little bit a little bit a little bit a little bit less black powder among other components. This will turn into a chunk. This will turn into a light yellow shiny chunk of gold, but this wouldn't. So you will have a problem. This wouldn't turn into a chunk. So the only point here is to have this powder here clean. Have a clean powder, and this will only take place if you do the filtering process right. Uh, we talked about the filtering process in a video. I will put the link of that video down below. Please check that out. If your um, gold powers in the last process isn't clean enough, you'll find some problems. So please make sure to like and subscribe, and hit that notification button. I will make some more videos about the whole process in the laboratory. Please check those out and take care.